This lesson is on vertical motion. So our objectives today is to apply quadratic models to vertical motion. And we did the activity called follow Javert. What we found out is that for any object, any object that falls vertically, we can describe this as some distance as a function of time. In fact, we found out our equation was d equals 16t squared. This is true for any vertical motion type problems. No matter if it's falling or launching in the air, we know gravity takes an effect. So in general, we can actually describe vertical motion in this form. H equals negative 1/2 gt squared plus v sub 0 t plus h sub 0, where g in fact stands for the acceleration due to gravity. If we're in meters, we use 9.8 meters per second squared. If we're in feet, we use 32 feet per second squared. This is a constant. Our v sub 0 stands for the initial velocity. Now if you're dropping something, our initial velocity is 0. But if you're throwing something at a certain speed, we can sub that in for that variable. Our h sub 0 stands for the initial height at which we drop an object or throw an object. But this is the form for any vertical motion. Notice how it's a quadratic, as h is a function of time, t, per seconds. So let's apply this. Let's take a look at this example. It says, Mr. McNally jumped off a cliff into the ocean in Acapulco while vacationing with some friends. This is a true story, back in 2005. In fact, me and my friends were able to model this function by this equation. H of t equals negative 16t squared plus 16t plus 480, where t is in time in seconds and h is in height in feet. Now, if you think back to our vertical motion equation, this negative 16 in front of t squared represents negative 1/2 gt squared. So g in our case is going to be 32 feet per second. It makes sense. We're in feet. Our 16 represents my initial velocity at which I took off. So you can think of 16 as 16 feet per second. And this 480, remember, represents our initial height. So, 3 questions I want to know. I definitely want to know how high I got on my jump. Now I know it's going to be slightly above 480 feet because I do have some vertical. I also want to know how long it took me to reach that maximum height. So how many seconds it actually took to reach that max height. And then my last question is, how long was I actually in the air? So how long did it take for me to hit the water? So let's use our calculator. We have an equation. So on our calculator, we're going to y equals, let's plug that equation in. So negative 16. Now instead of t, let's use x as our variable to represent time. And our y in this case would then represent our height. So if I type the equation up, negative 16x squared plus 16x plus 480, I press graph. And you remember, if we're in standard viewing window, you'll notice something strange. In fact, our parabola is a little bit off the charts. I want to find the max height. So I can use my zoom features here. One option is you could do zoom out. You could also manually adjust the window, but there's this really nice feature called zoom fit. If you press enter on zoom fit, what's nice about this, it'll show you some key features of the parabola. Key features as in my maximum point, my zeros, as well as the y-intercept. Now the first question asks, what was the highest point I reached? So remember, to find the maximum height, we use second trace, and we use our maximum option. So pressing enter, this is where we need to do our left bound, right bound. So we need to get our cursor left of the highest point, enter, and then we just make sure our cursor is right of the highest point, pressing enter. One more time gives us our highest point. So if we interpret this x, y, remember x represented time, our y represented height. So we could say that we actually have 2 answers here. In fact, we have the highest point at which I reach, which is 480 feet. And we actually have the time at which I reach that. That's this 0.5 seconds. So we can interpret the x-coordinate again as time and our y-coordinate again as our height. Now the last thing I want to find is when I hit the water. Well, that's finding the 0. So pressing second trace again, using our 0 option. Now remember, when we're doing this option, we want to get our cursor as close as we can to that point, pressing left, enter, and twice right, enter, making sure that our arrows were within the region there. Pressing enter one more time gives us our 0. Why do we want a 0? Well, we want when our height is 0. So therefore, our answer, if you notice, our x-coordinate would be 6 seconds. So 6 seconds in the air on this fantastic jump. Let's take a look at this example. Back when I was on the PGA Tour, which was long before my snowboarding and even long before that vacation of mine, I actually sunk a phenomenal eagle flop shot out of the bunker, and I actually swung with it about an initial velocity of 45 feet per second. My question to you is, what was the maximum height of this golf ball? Let's take a look at this phenomenal shot of mine. Now, as you can tell, I had black hair, and I was a little bit shorter at that time, but this was actually on a par 5. So again, the question is, what was the max height that this phenomenal shot of mine reached? Now the problem is we don't have our equation for us. So let's use our vertical motion equation. In fact, we got to pick out some known values here. What's kind of hidden here is the gravity. Since we're dealing with feet, we'll consider our 32 feet per second squared as our constant due to gravity. Our initial velocity that I swung at was given in this problem, so it was 45 feet per second. And we can say that our initial height here is 0 because I'm hitting it off the ground. So if you remember our vertical motion formula, was negative 1/2 gt squared plus v sub 0 t plus h of 0. If we sub in our known values of gravity and our initial velocity, we can simplify this to be negative 1/2 times 32, giving us negative 16t squared plus 45t as my equation. Well, we have an equation. Let's use our graphing calculator now. So let's go into our y equals. Let's type negative 16. Now instead of t, we're going to use x again, so x squared plus 45x. Now if we go to zoom standard, you'll notice something similar like the last example, that my parabola is a little bit off the charts. So we could use our zoom options here. We could do zoom out or that zoom fit if we really wanted, but in reality, if you take a look at the graph, we just need to expand it just slightly. So if we go to our window here, we can go down to our y max and just expand that to a little bit beyond 10. So maybe 40. If we graph, you'll notice that now we can clearly see the maximum height, which is what we want to find. So remember, to find the maximum height, we go to second trace. We use our option of maximum, enter, and again, we want to be left bound, right bound, so get our cursor as close as I can to the top. We want to be left of it, enter. We want to click right of it, enter. And enter one more time, giving us our maximum height. So if you notice, our output, remember, is height. Our x values represents t in time. So our answer here would be, well, it reached about 31.64 feet in the air. So this concludes our lesson on vertical motion. Come tomorrow, hopefully with the equation written down in your notes somewhere, because tomorrow we're going to practice some of these other problems. Have a good night.